Let's keep talking about Lisp. In this case, we're going to talk about Lisp sites. Lisp sites will contain endpoint identifiers that are used to identify devices. Notice we are not saying it is a specific IP address. It can be an IPv4 address. It can be an IPv6 address. It is just an EID. Also, routers that connect Lisp sites to a Lisp domain can be ITRs, ETRs, or XTRs. The ETRs will map one or many RLOCs, router locators, to EIDs. And notice also that we are not saying that RLOCs, router locators, are neither IPv4 or IPv6 address. You have the freedom to choose IPv4 or IPv6 address for the RLOCs, or IPv4 or IPv6 address for the endpoint identifiers. So in this example, if you are sending traffic from the Lisp site into the Lisp domain, this router will be behaving as an ITR, or ingress tunneling router. It is ingress because it is injecting traffic into the Lisp domain, and it is tunneling because it will create a tunnel. Remember that Lisp uses tunnels. Whereas the traffic that comes from the Lisp domain into the Lisp site will have to use a router that performs the functions of an ETR, or egress tunneling router. Notice that the traffic is coming out of the Lisp domain. That is why it is an egress tunneling router. And it is tunneling because it is receiving the tunnel, and it will have to de-encapsulate the traffic in order to deliver it normally into the Lisp site. In this case, which is a very basic case, this router has only one interface into the Lisp domain, and it can be this the IP address that belongs to this interface can be chosen as the RLOC. So if that is the case, this ETR should advertise the RLOC to EID's mappings for this example, and this will be that mapping. We'll have one RLOC, which is 10.1.1.1, which is this the IP address that belongs to this interface, and the EID will be 172.16.10, and the other mapping will be the RLOC that will be 10.1.1.1 to the other EID 172.116.2.0. These mappings come from here. So notice that you could use IPv4 for the RLOC, or IPv6 for the RLOC, and IPv6 addresses for the EIDs. In a more complex example, you can have a router that has two interfaces, and this router can also advertise this mapping, but it will be more complex because it will have two interfaces. So now 4 mappings have to be done. 2 mappings for this RLOC and 2 mappings for the other possible RLOC. So when you have these kind of scenarios, you have to set up priorities in order to choose from where you want, from what interface you want to receive the traffic, and the priority matches. You will have to use wait in order to load balance the traffic. This case can also happen if you had 2 routers. In this case, you will have also to create 2 mappings for this RLOC, and this other router will create 2 mappings for this other RLOC. Priorities should be set in order to know what will have more priority over the other, and if both has the same priority, then the wait will start to matter in order to load balance the traffic. That's it.